Hey kid, do you want to learn math?
Sure.
Good, because you have no choice in the middle.
Okay, so for this equation, our equation is f of x equals 3 over x minus 2. And you guys already know how to do the x-intercept and the y-intercept, so I'm going to be going over the vertical asymptotes and the horizontal asymptotes. Okay, so for the vertical asymptote, you're going to set the denominator equal to 0. So our denominator is x minus 2. So 0 equals x minus 2, and you're going to just solve for x. So that's why I just did plus 2 on both sides. So our vertical asymptote is going to be x equals 2. So for the horizontal asymptote, what you do is you're going to look at the equation and you're going to look at the degrees of the equation. So for this one, our degrees are the same because we don't have any exponents in either of them. So the exponents are going to be the same, which is just like 1. So I'm going to take the ratio of the leading coefficients. So what I do with that is I have 3 over 1, which is equals 3, and that's the horizontal asymptote.
Okay, so this is the orange equation, and it is f of x equals x squared minus 16 over x squared minus 9.
Okay, so in the previous, you guys already know how to do the x-intercept. What? The x-intercept. So
Set the fx equal to 0. Just set the whole thing equal to 0, just the numerator.
yeah, you're gonna get rid of the denominator and you just focus on the numerator. You're gonna solve for x.
Yeah.
So, and then in the y-intercept, you're going to just replace all of the x's with zeros, and you're going to just solve for
And
y.
one thing you might be wondering is why there are two x-intercepts and they're the same is because we have squares and we need to take the square of those x's when we solve for the x-intercept is you have to put a plus and minus sign because they could be both negative and positive numbers.
Yeah, so, and then for the vertical asymptote, what you do is you set the denominator equal to 0 and you solve for x. So, like Maddie said, whenever we have a squared, you're going to have to undo that square with the square root. And when you square root 9, you're going to have, you have 3. But if you do the plus and minus, you're going to have negative 3 and positive 3. So, but right now we're going to be focusing on the horizontal asymptote. So when you're doing the horizontal asymptote, you're going to look at the equation and you're going to focus on the degrees of the equation. And how you determine the degrees is you look at the exponents of the equation. So both of these are 2. So, and whenever your degrees are even, you're going to take the ratio of the leading coefficients in your equation. So that just means that it's 1 because we don't have any numbers in front of the x. So that just means that it's 1. So our horizontal asymptote is going to equal 1.
Woo. Okay. It's recording.
We won't worry about those. It's on the way right now.
Has to run this way. Okay, so today we are learning how to solve x squared minus x minus 2 divided by x minus 1. And this is going to be one of our more difficult problems, but we'll show you how to do a multitude of things. So we go to the first step, and the first step is solving for the x-intercept. This means the y-intercept is 0 and crosses the x-axis. Yeah? Wrote that wrong. The first step is you have to set the equation to 0. So we put 0 equals x squared minus x minus 2 over x minus 1. The next step is you multiply both sides by the denominator to cancel the denominator out. So you can simplify further. So we multiplied x minus 1 times 0, which is 0, and then x, the whole equation, times x minus 1. So these two cancel each other out. Now you have to use the Lopez method, which is finding the factors of x squared and minus 2 and making sure they add up to negative x. Then you cross multiply, so you can see here x times x equals x squared, and negative 2 is 1 and negative 2, and so when we multiply negative 2 times x, we get negative 2x, and 1 times x, we get 1x, and when you add those together, you get negative 1x. Now you have to, now you have the x-intercepts by adding across, which I mean by this, I mean solving for x. So basically, you take these two factors right here, x and 1 and x minus 2, and you need to set those to 0. So I did this here, and I said solve for x. So we have x plus 1 equals 0, minus 1, x equals -1, and then right here we do x minus 2 equals 0, plus 2, so x plus 2. Now you have your x-intercepts, which are -1, 0, and -2, and positive 2. Okay. The second step is solving for the y-intercept when the x value is equal to 0. Basically, that's what it is. So you have to set all the x's to 0. So f of 0 equals 0 squared minus 0 minus 2 over -1. Woo! Now you have to solve by simplifying. So now you have your answer 0, -2 over -1. That is your y-intercept. Hooray! Now we're going to start with how to find the vertical and horizontal asymptotes. To find the vertical asymptote, set the denominator to 0 and solve for x. Now we remember that the vertical asymptote is imaginary because a number divided by 0, wait, no, sorry, anything divided by 0 is not,
Is 0.
Yeah, is 0. Yeah, and that's why you get an error on your calculator. So we have to set the denominator, so now it's x minus 1 equals 0. So 0, solve. So now, as you see, x equals +1. Your vertical asymptote is +1. Now you graph. It's an imaginary line, so here is +1. Just goes up and dotted. Now we find the horizontal asymptote, and there are many rules for those which we'll cover, but the one we're focusing on right now is because the denominator being smaller is smaller than the numerator, there is no horizontal asymptote, so we don't have to draw that on our graph. Graphing and table. To find the graph and table of the whole equation, you have to use the slant equation. Slants are difficult to solve, but the first step is you need to put your denominator on the outside of a long division symbol. So basically we're just long dividing. And technically what we do is we first look at the x squared. We see how many times is x go into x squared, and that equals x. And cross that out. It's x. So put x up here, right? Then go down. We see how many times it's all go into each other. So now we have x minus x. Bring down that 2. And now we have x equals x plus 2 minus over -2 over x minus 1. So your slant is just x, which is pretty simple. But we still have the remainder. Where is that remainder? Remainder, which is remainder over divisor. So that is that right here. So now you can see we graphed it all. The table we just plugged into the calculator, so that should be simple enough to understand. In the graph, here's the slant, here's the vertical asymptote, and we have no horizontal asymptote. And here is where you plotted the points from your table, which are very decimals, but you can get them plotting them. Okay, so that's the first part. Now we'll go on to other problems. Okay, for our last problem is x to the third power minus x to the second power minus 6x over negative 2x squared minus 6x plus 8. Now we've already done everything, so solving for the x-intercept, we do Lopez method again, and we have to put x on the outside this time because we need to get everything squared away. And so the x-intercepts are 3, 0, negative 2, 0, and actually there'll be a 0, 0, but the y-intercept is you have to put everything, you have to put all the x's to 0, so we put over that over -2, and so that is 0, 0. Horizontal asymptote, there is none. And for the vertical asymptote, well, it seems that it is x equals 1 and x equals -4. Here's the table. We plugged it into the calculator, as said. And here's the graph. And the next part will be my partner showing you.
Okay, now I'm going to be explaining how you do the slant of this equation. Okay, so you're going to put the denominator on the outside and your numerator on the inside of the house. Okay, so we have our denominator, and that's negative 2x squared minus 6x plus 8. And we have our numerator on the inside, and that's x cubed minus x squared minus 6x. And you can see on the end I put a 0, and that's just to put a placeholder right there because I'm gonna have to need that later, and that's just so I won't be confused and have an extra space for no reason. Okay, so now I'm going to see how many times x cubed can go into 2x squared. So I go over here and I divide it out, and this is how I did it. It's like x divided by negative 2 times 2 x's. So I got negative 1/2 x, and I put that on top. And I see how many times negative 1/2 x can go into 2x squared. So that is going to go in. My 2 is going to cancel, and I'm going to be left with x cubed. And then I see how many times negative 1/2 x can go into negative 6x. So I get positive 3x squared because negative times negative is a positive. And then I do that one last time with the plus 8, and I get minus 4. So as you can see, I have all of that right here, and all I do is just subtract that. So my x cubes cancel out, and my negative x squared minus my positive 3x squared is going to come out to negative 4x squared, and my negative 6x minus negative 4x comes out to negative 2x.
That is the copier.
And I bring down my 0 because that's just my placeholder, and that happened with that. And then I come out to the side again, and I see how many times this can go into that. So I get 2. So because I have 2 times negative 2x squared, I get negative 4x squared. And that comes down to right here. And then I see how many times 2 can go into negative 6x, and I get negative 12x. And I do the same thing with 8, and 2 times 8 is 16. So I do the same process again. I just subtract it. That cancels. And negative 2x minus negative 12x, I get 10x. And I just bring my 16 down. And this is going to be my remainder because I can't put 10x into negative 2x, so that means I have to stop. So 10x plus 16 is my remainder, and I put that over my denominator, which is that, and my slant comes out to negative 1/2 x plus 2. So that's my slant, and that's my remainder.